happy Halloween weekend. Shout out to everyone who came to the dance and haunted house. I hope you had fun. All right, so let's talk about unit rates. All right, so what is a unit rate? Well, a rate is when we're comparing two quantities that have different units of measurement. So like beats and minutes, or beats per minute. Or we have 750 words on 3 pages, so 750 per 3 pages. A unit rate is a special kind of rate, kind of like a proportional relationship is a special kind of linear relationship. And a unit, it's like 1 unit, a single unit. So it's a ratio that one of the numbers is 1. So we're comparing it to 1. So 250 words on 1 page. How much money is it for 1 gallon? How many beats in 1 minute? So the second thing that you're comparing always has 1. So that number 1 is important. It's 1 unit. So here's some other examples. So a rate. These are all rates. And a rate, even if it's a unit rate, it's still a rate. So 50 miles per hour, 500 words in 20 minutes, 60 inches in 5 feet, 25 adults in 5 cars. The unit rate now takes all of the second numbers and makes them all 1. So it's 50 miles per 1 hour, 25 words per 1 minute. It's kind of like taking your ratio and simplifying it, reducing it. 12 inches in a foot or in 1 foot, 5 adults per 1 car. So now the second quantity here is always 1, so we just reduced. This is helpful when you're trying to compare prices. Think about when we were talking about the proportional relationships and whether the sale prices were proportional. Okay? If it's $6 for 6 oranges, costs you $2.34. Well, how much is it? So what is the price for 1 orange? So it's $2.34 for 6 oranges. So what's the price for 1 orange? We represent that with an X. All you need to do is divide the numerator by the denominator. So you do $2.34 divided by 6. You could also cross multiply the butterfly method and you get 234 equals 6x, then you're dividing by 6, but that brings us right back to what we had. So for 1 orange, it is 39 cents. So it's 39 cents per orange. Okay, how much is it for 1? Here we have a table. Okay, let's look at this here. What's the unit rate? So students, pencils. How many pencils per student? There are 3 pencils for every 1 student. So it's 3 pencils per student. How can we find this in the table? The unit rate is for 1 for the x. So it's y divided by x. And you want that x to be 1x. So right here we see for 1 student it's 3 pencils. So it's 3 pencils per student. We could find that by doing 6 divided by 2. Our ratio of y divided by x gives us 3. So that k, our constant of proportionality, is also our unit rate. Well, what else does that mean as our unit rate? What else do we call our constant of proportionality? And this is what we're going to be talking about tomorrow. So those of you who are watching, thank you. You're already getting this preview. The slope. The slope of this. So we're adding 3, adding 1. Our slope is 3. Our constant of proportionality is 3. And our unit rate is 3. So here we said number of round tables and the number of chairs. So we have round tables, and the number of chairs at each round table is proportional. Well, we can't really tell what that number is here for 1. So let's look at 2. So we make a table. So for 2 tables, we have 10 chairs. We're here at 4 tables, we have 20 chairs. If we were to find the slope here, we went over 2, we went up 10. What's 10 over 2? That's 5. What's our slope? Plus 10 plus 2. 10 divided by 2 is 5. What's our constant of proportionality? Our y divided by x. 10 divided by 2 is its proportional. We go through the origin. 10 divided by 2 is 5. 20 divided by 4 is 5. So our unit rate, our slope, our constant of proportionality is 5 chairs per 1 table. All right, here's what I would like you to do. I would like you to give me the unit rate for miles in both Madeline and Louis's cars. So give me the unit rate for the number of miles, okay, per gallon. So I should put that here. Number of miles per gallon for Madeline and Louise's car. And then give me the unit rate. What is the price per can of soda? So if a 12-pack is $7.92, what is the price per can of soda? All right. Thanks. Bye.